All right, good morning, everyone. So this talk is going to be about the way that we use Erlang and Ruby together to solve some interesting problems at Rackspace. So a lot of you have probably heard of Rackspace. We do a lot of hosting. Whenever I say that I'm using Erlang at Rackspace, most people ask me right away, says, oh, do you work in the cloud or do you work with OpenStack? And in fact, I don't. I work in the foundation group, which supports our traditional managed hosting business, where we have a lot of interesting automation problems. So the team I work on is called the Foundation Development and Automation Team. That's right, FDAT. You can overhear some interesting conversations where people say, oh, who do I go to talk to about that APIs, FDAT? So what do? We are a little bit unique, I think, in that instead of a team mission statement, we have a team mission haiku. Through automation, adapt and collaborate, deliver software. I'm sure that clears it all up. So what we do is we build automation tools and APIs. We have two project teams right now. One focused on storage, so SAN, NAS, and DAS, and my project team is focused on networking devices. So what do we do? What do I mean when I say automation, right? So kind of the basics is we back up devices. We have SLAs with our customers that say if the device goes bad, we have a certain amount of time to restore it, or we owe them a refund. So having backups is very important. And basically a backup for a device is everything required to get that device running in the state that it's currently in after a hardware failure. We also do updates. We have a lot of devices, and we occasionally have the need to go out and, for example, update all of the firewalls in a certain data center to add a new SNMP polar. Obviously, at the scale that we work, that's a lot of devices to update by hand, so we have some tools to do that automatically. And we also generate new configurations for devices that are just going online. It's kind of one of those things that doesn't really involve communicating with the device, but it landed on us because it didn't make sense for anybody else to do it. We're also doing some more advanced things now. We've kind of got the basics handled. If you use the myrackspace.com portal, there is a firewall manager which allows you to add and remove ACLs from your firewalls. We provide the API that backs that up. Rackspace is also working on a new project that we're internally calling NTAS, which is Network Topology as a Service. So we go out and we spider all of our switches and devices that are attached to them, and then feed all that data into a service so you can ask interesting questions like, how many devices are plugged into this switch, or which devices are behind this firewall, because of course the logical and the physical layout of the network are not necessarily the same. So that's a very interesting project. And one of the things that we're working on a lot now is an API for doing Vlan assignments on the switches. This is something that we do a surprising number of times every day. In our data centers, as we have customers churn or new customers come in, we have to set VLANs on the switches that they're plugged into. Also in our offices, as people move around to new desks or we add people, we have to set their VLANs properly so that they get access to the things that they need access to. And so this alone will end up saving hundreds of man-hours every year. And we do all of this using Ruby, Erlang, and MongoDB. I think maybe if I add Node.js to that slide, we'll be fully buzzword compliant. So I mentioned before that we have a lot of switches. I don't know about you guys. I am impressed by big numbers, so I'm going to throw some out here. We have 50,000 network devices total. A little more than half of those are infrastructure switches, and the rest are customer devices. We have, in terms of firewalls, about 18,000 firewalls. Our most popular model is the Cisco ASA, which is a real workhorse of a device. We also have about half as many Cisco PICs, which we are trying to get rid of as fast as possible, but we have a lot of customers who say, you know what, it does what I want, I don't want to get rid of it. And we recently introduced the Juniper SRX. We also support a lot of load balancers, the Cisco CSS, the F5 Big IP, which is very popular right now. the Brocade ADX, which we recently introduced, the Red Hill WebMux, which is a piece of crap, and the Cisco ACE. I would personally love to go through our DCs and pull out every Red Hill WebMux and beat it with a baseball bat, but they won't let me do that. We're getting more into our managing infrastructure switches lately, which we have the Cisco Catalyst 2950, which is an older model, the Cisco Catalyst 2960, which is kind of our bread and butter access switch, and the Cisco Catalyst 4948, which we use as aggregation routers. Now, you do not be fooled by the fact that these are all called Cisco Catalysts. These are very different devices, and you have to interact with them very differently. Thank you, Cisco. All of these devices are spread across 8 data centers on 3 continents. North America, of course, where we have 6 data centers. Europe, we have our second largest data centers in London. And Asia, where we have a small but growing presence in Hong Kong. It used to be the case that all of our services were hosted here in the US in one data center, and we have considerable latencies between London and Hong Kong that we have to deal with. So some of the challenges that we've run up against when trying to automate all of these different devices in all of these different places, obviously the number one challenge is there's just a lot of devices. We also run up against some significant performance problems. These devices are just not designed for high throughput management. They can pass packets all day like a boss, but when it comes to going in to manage them, not so much. The other thing is that some of these devices, like for example the Red Hill WebMux or the Cisco PICs, they're just slow. They're old, right? Some of these things are running on 200 megahertz Pentiums, right? They're just slow and they're not going to get any faster, and we don't have the luxury of just throwing them all out. And the really kind of the biggest performance issue is we spend a lot of time in network I/O and just waiting on the device, and that's not going to go away. The other problem we run into is transparency. With this many devices, some of them are going to fail every night. It's just a fact of life. And we need to know which devices are failing and why. A lot of times it's just basically down to a simple configuration problem, but sometimes it's actually a serious issue with the device getting ready to fail. And if we can get on top of that before it happens, well, that's a win for our customer and it's a win for us. And we need to keep a record of all interactions with the device. Some of our data centers are PCI certified. We actually follow, I think they call it SSAE 16, used to be called SAS 70. Basically, we set controls on how interactions with our devices are managed, and we're audited based on that. There are controls, so we can say whatever, right? But we are very serious about protecting the integrity of our customer devices, and so we need an audit log. We need to be able to say, oh, look, customer's device is compromised. We need to know why that happened and who was involved. The other problem we run into is with the multiple device types. Remember that list of about 6 load balancers? Well, they all behave differently. And you have to take that into consideration when you're communicating with the device. And even the same hardware platform with different versions of the OS, particularly with Cisco devices, you will run into some really weird idiosyncrasies and differences that you just have to accommodate. Cisco is very bad about regressions between code versions. We ran into a situation where a specific code version running on the Cisco ASA would lock up if you tried to write the configuration from the active device to the standby, something that you probably want to do every once in a while. So we have to take all those things into account and compensate for them in our software. And probably one of the biggest challenges is management interfaces. For most of these devices, the management interface is SSHing in and using expect to manipulate a command line session. Not exactly high tech, welcome to 1999, but it's kind of what you got to do. Some of the newer devices have real management interfaces. I like to say that the Cisco devices are meant to be managed by a human and not so much by a computer, whereas the Juniper devices are meant to be managed by a computer and not so much by a human. That means that our support floor doesn't like the Junipers, but I personally love them. A little bit of a conflict there. So the Brocade ADX and the F5 both have SOAP-based interfaces, but of course they're different. The Juniper has an XML-based interface that is based on netconf, which Cisco in theory supports, but not really. And then SNMP has its own issues. We ran into a situation last week where the SNMP MIBs that we use to pull physical port numbers on the 2950 and 2960 are not supported on the 4948. And we asked Cisco about that, and they said, huh, we'll get back to you on that. So where we started, I joined Rackspace in mid-2009. And at that time, there were multiple Rails applications, and in one case, a Ruby script. They had a lot of overlapping responsibilities. They were basically information silos. They all communicated with devices in one way or another, but they did it differently. Of course, it was difficult to change, right? All of the standard problems you think you'd run into. And they were using expect.rb to communicate with the devices, which reads the input one character at a time, which is very slow. This was obviously not tenable. We were using MySQL on the back end for the database, which, I mean, MySQL is a fine piece of software, don't get me wrong, but we had some very kind of specific issues in our circumstance. We had about 260 gigabytes of poorly indexed backup data. Migrations were basically out of the question because of the poor indexing. And adding proper indexes was also pretty much out of the question because we'd have to take the master database offline for a weekend while it did the indexing. Another interesting problem we ran into is that with all these different devices, doing a backup on a device means different things for different types of device. And MySQL having a rigid schema really was a problem because we'd want to store different information based on the type of device we were backing up. We dabbled a little bit with vendor device managers. So Cisco has a device manager for their firewalls and a different one for their load balancers. F5 and Brocade both have their device managers. These were a problem for us. They were expensive, often very much so. Typically, they would only support a small number of devices per instance because the vendors were not expecting someone to need to manage multiple tens of thousands of devices. And at the end of the day, you still have multiple management interfaces that you've got to somehow kind of abstract over so that you can pretend that you have a somewhat homogeneous network. We looked at third-party solutions. I'm not going to name any names here, but we looked at quite a few of them. Most couldn't handle the scale that we operate at, and most couldn't handle the heterogeneous network. They may have supported maybe half the devices that we needed to talk to, and when we said, well, what about supporting the other half, they said, well, good luck with that. And really, I think the most important thing is that we have a large, very complex existing network, and we simply cannot change the way our network is built out to support a tool. I mean, it's not going to happen. And in fact, it's probably more accurate to say that we have a large and complex infrastructure network with thousands of customer networks attached to it. So it's not just an issue of managing one network, it's an issue of managing thousands of networks. And if our customers come back to us and they say, you know what, we want this crazy-ass configuration, we want tiered firewalls, we want multiple layers of load balancers, we say, yes, sir, when do you want it? So where we are today, we're in a much better place. I think one of the key things to take away from this is that we always built the simplest thing that could possibly work and then grew from there. So we started out by taking those multiple Rails applications and collapsing them down into one, and we replaced MySQL with MongoDB. MongoDB very much fit the way we wanted to work. Basically, you know, all I really want is a big persistent hash that I can stuff things into and get them back later, and that's exactly what MongoDB is. We then added an Erlang component to handle the actual communication with the devices. We have to talk to many devices at once. We have to do so in a way where there are no failures. Well, we have to do so in a way where our code doesn't fail. The devices are going to cause all kinds of problems. We may not be able to talk to it. We may have a device that disconnects in the middle of the conversation. We need to capture that, we need to record it, and we need to get a ticket off to the right person to fix it. So our Erlang application basically just started off simply sharing the database with with the Rails application. And that actually worked out quite well. MongoDB has atomic writes, so we just don't overwrite the whole document, and things worked out. And then, of course, all of our network device communication happens here. Eventually, we found a need to add a REST API as we needed more immediate interaction between the Rails application and the Erlang application. And we used Web Machine for that, which I can't speak highly enough of Web Machine. And we use it quite a bit. And then eventually, we added other clients talking to this REST API as we started building out the API. So as the results of that, we went from taking about 8 hours to back up our largest DC to 38 minutes. And I'll get a little bit into the architecture of our backup application in a minute, but we were actually able to ramp up the number of backup workers to the point where we started having problems with the network infrastructure. Our backbone team called us up and said, you know what, guys, you are causing problems on our TACAX server. You need to back off a little bit. All interactions with the device are logged with details of what happened. And of course, it's all very maintainable. It's very easy to maintain now. There's a clear separation of responsibilities between the Rails front end and the Erlang back end. And as a development team, that makes us very happy. So the device interactions are fast and reliable. We went from taking probably on average 45 to 60 seconds to carry out a conversation with a device. That's down to like 12 or 13 seconds now. And if communicating with a device fails, we use the normal error handling mechanisms within Erlang to capture that and log it. We have full transparency. Everything that happens with the device is logged. And we have a better foundation for growth. So this is a screen capture of the backup results page that I took right before I came down here. And by the way, this 2% failure rate is embarrassingly high. We're growing very quickly, and our provisioning process is not as automated as we would like, and so we have a lot of devices that are going onto the network not configured properly. A typical error rate for us is about 0.5%. On this day, we had 404 errors out of 20,000 devices, just over 20,000 devices backed up. So in this screenshot, this is a list of all of the events for a single device. We categorize them by type, so whether it was a scheduled backup job or an API call, and the results, whether it was successful or not. And for each of these events, you can drill down into the specific details, how long that interaction took, who initiated that interaction. In this case, it was a backup, so it was initiated by the system, whether it was successful or not, what the results were. In the case of a backup, if we try to back up a standby device, that result will say standby instead of changes saved. And if there were no changes on the device to save, then that result would say no changes. And the power of MongoDB really comes through in that details section. That is a piece of structured information that is different depending on what type of event we're recording. So if this were an API interaction instead of a backup, then you'd see details about what was changed on the device instead of this. And this basically shows each stage of the backup and the results of that stage. And you see saved is underlined there. That is a hyperlink to the saved backup. And this is very important for our network security technicians who are trying to manage these devices and interact with the customer. Whenever somebody comes along and says, why isn't my device backing up, or why can't I talk to it via the API? It's like, well, it's right there. Go check that out. So I'm going to talk a little bit about some of the high points of the application. I'm not going to go into a lot of detail on the whole thing, but there are three libraries that we've broken out of the main application that I think are pretty interesting and pretty relevant to what's going on. And so the first is the command line automation. This is one of those things that we'd rather not do, but we have to, so you might as well make the best of it. And from our application's point of view, we have an agent that represents a command line interaction with a device. And on the back end, that interaction could happen over HTTP, over SSH, or over Telnet. And one of the interesting things about SSH is that those PICs I mentioned earlier, yeah, they only support SSH1. Any guess on how many libraries there are out there to do SSH1? Yeah, not many. There's one, it's written in C, and it doesn't work very well because nobody's maintaining it. So what we had to do here, we have to support those devices. We've got to do something. SSH1 is the only protocol they'll communicate over. So we had a piece of Ruby code that would fire up OpenSSH on a PTY and use expect to manage that interaction. And it turns out, by the way, that there's a library called rexpect, which reads in input in chunks instead of one character at a time and is thus much faster. Pursuing that, we have a library for calling Ruby code that we call GenScript. It's actually based on some code that we pulled out of the Ernie application that was written by Tom Preston Warner of GitHub. Ernie is an RPC server that allows you to implement the code for your RPC in either Ruby or Erlang. We didn't really want an RPC server. We wanted a way to call Ruby code easily from within our application. So we kind of stole the guts of that code that manages the Ruby scripts and set it up so that we can just call arbitrary Ruby functions from within our Erlang code. So for those of you who were here to see the Ruby and Erlang working together, these are the money slides. So here we have a Ruby module, hello world, right? Not very complicated. The magic here is in that last line, GenScript expose the hello module. With this, we can now write Erlang code that looks like this. We call GenScript to start it up. We pass in the fact that it's Ruby and the path of the script. And then we can use call to call functions in that module. And this works really well. There's nothing in here that is necessarily specific to Ruby. There's a little bit of a shim to manage the interaction, right? Basically, all that happens here is we start the Ruby interpreter on an Erlang port, and we have a little shim of code that when we make the call to the Ruby application, on the Erlang side, we convert that to BERT, which is binary Erlang terms, also from GitHub. We convert that to BERT. We send it down file descriptor 3. On the Ruby side, there's that little shim that takes that, converts it from BERT, figures out how to dispatch that function to the module, calls the function, captures the result, packages the results up as BERT, and then pushes up file descriptor 4. On the Erlang side, we catch that, decode it, and return it up the stack. This is very cool. We use this a lot. There are several situations where we say, hey, we have this thing. It's not that big a deal. We're not really sure how to do it properly in Erlang, but hey, we've got this Ruby code to do it. Well, bada bing, bada boom, right? It's not appropriate for everything, right? We thought we had some issues with the Erlang SNMP manager a little while back, and we said, oh, hey, this is no problem. We'll just write a Ruby script and use the Ruby SNMP manager, and that'll be great, and it did not work out so well. But at least it was an option, and it was easy to experiment with, so we figured out very quickly that didn't work, and moved on to something else. So we have another library which we call GenBatch. This is for running batch jobs, and for us, a batch job is something that we run entirely for the side effects, right? So we have, in our case, we have a big list of devices. We want to update that, all the devices in that list, or we want to back up all the devices in that list. So we want to hand that list of devices to a certain piece of code. We need to keep the number of workers that are doing this. We need to kind of pin that number at a certain level. So we have this pool of asynchronous workers. They process the items on the list one at a time and until that list is empty. This is kind of at a high level the way this works. So we have this runner, which is kind of our error kernel, right? We don't expect the runner to ever crash. The runner will spin up a bunch of workers. These workers we don't care about. They can crash, whatever, blah, blah, blah. And the workers actually delegate the actual processing of each item to a callback module. And the callback module also has some callbacks for certain events. So if a worker does crash, we call a callback on the module to say a worker just crashed, so you can log that. The interaction between the runner and the worker looks something like this. The runner will start the worker. The worker will send back an asynchronous, hey, I'm ready message. The runner pops an item off the stack, sends a process message to the worker with that item. The worker then calls the callback module. When that is done, it returns a ready message to the runner, says I'm ready for the next one. We lather, rinse, repeat until there are no more items in the queue, and then we start, the runner goes into a wind down status, and it starts sending stop messages to the workers to say, okay, we're done. This has been great. We can scale up and down the number of workers as necessary. Some of our smaller DCs, it doesn't make sense to spin up a lot of workers. Some of the larger DCs, we want a lot of workers. And as I mentioned before, we have to be careful about stressing the network infrastructure. So what's next? We're kind of moving from being a full stack tools provider to an API provider. And there are a lot of groups working on automation within Rackspace, and they're working on automating different things. And we have kind of carved out a niche in that we are responsible for device communication. If you want to talk to a device, you come ask us, we'll handle it. The idea is that eventually we're not going to have people logging onto network devices. It should all be automated, or it should all go through a tool. That is obviously a big in the future goal, but that is what we're working towards. We're also finding that as we shift more to a focus on APIs, that there are some better ways to structure our application. And in particular, one of the things we're working towards is removing the fact that the Rails and the Erlang application are sharing a database and just having the Rails application work directly from the REST API. And then we can say, when people come along and say, well, do you support this? Like, if you can access it in our front end, you can access it over the API. And this also solves a lot of problems that we currently have, where we have validation logic or certain business logic duplicated between the Erlang and Rails applications. For example, we have a bit of code to determine if a device is eligible for backup. So it has to be in a certain state, it has to not be excluded, it has to be currently active, it has to have a primary IP assigned to it, these sorts of things. And we have to do that in two places now. We have to do that in the Rails application when displaying that device to the user, and we have to do that in the Erlang application when actually deciding whether we're going to back up that device. So by moving all of the actual business logic down into this Erlang application, exposing it through the REST API, we get a big maintenance win. And actually, once we move to this, we don't necessarily need Rails in that spot. That could be Backbone.js or whatever. If any of us like JS, we might do that. But I think we'll probably stick with Rails. So I think one of the interesting questions, or one of the interesting points for me is how we got here. Rackspace is not typically known as being on the bleeding edge of technology. A lot of people, even within the company, are kind of surprised to hear that we are working with Erlang. So basically, we put together a case, argued the benefits, and won over our boss to the fact that this is the way we need to go. And it took about 6 months. There are a lot of discussions, right? I go to my boss and I say, you know what? These problems we're having, this would totally be a lot easier to solve if we were using Erlang rather than Ruby to talk to the devices. And he's like, okay, if you say so. But we really don't have time to rewrite that right now. It's like, well, I'm just telling you, We go back and forth on this for a while, and eventually I go in and I have that meeting with him one day, and I say, you know what? This would be totally easier to solve if we were using Erlang. And he says, yeah, you said that. How long do you think it would take? And then I knew. It's like, I got him on the hook. I was a bit fortunate in that my manager is not from a software development background. He is He's a former Marine, and he was managing network security technicians when the last development manager for our group said, I don't want to do this anymore. And they said, we need somebody to manage this development group. Hey, Brad, why don't you come do this? He's like, how hard could it be, right? Managing developers. That's got to be a cakewalk. And there was definitely at first some butting of heads. He's very much of the operations mindset. You know, it's like go, 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 do, do, do. We've got to make plans. We've got to document everything. It doesn't work that way. But he's very open-minded. He listened. So when we went back and said, you know what, there's a better way for us to develop software, and he said, okay, tell me what that is. He was very interested in becoming a better development manager. And as a result, we became a better development team. And so when we went back and said, we need to talk about the technology choices, he was open to listening to that. But of course, we had to back up what we said with actual results, right? When I said we could do this in Erlang, and he says, great, how long? At that point, now I'm on the hook to actually deliver this. But it worked out, obviously. We did run into some, let's say, some speed bumps from other parts of the organization. And I'm sure that a lot of you have heard these as well. Like, Erlang is weird. It's got a weird syntax. Doesn't run on the JVM. Oh my God, what are we going to do? And a lot of that, you know, addressing that, a lot of that is just education. You know, it's like, well, you know, Erlang is very good at some specific things. Look, we're not trying to rewrite Rackspace.com using Erlang. We have a very specific problem. This provides a good solution, and we want the ability to actually try that before you pass judgment. We also hear a lot, you can't find Erlang programmers. And that is, I mean, I guess there is some truth to that. To be honest, we have trouble finding good programmers, period. We are hiring Ruby, Python, and Erlang programmers, and it's not like we're inundated with Ruby and Python resumes. And really, a programmer who is worth their salt can pick up Erlang, like really. The last 2 Erlang programmers that we introduced to our team came in as Ruby developers. We said, hey, what do you think about trying out Erlang? They said, great, I'd love to. We start them off on simple tasks. They picked it up very quickly. And there was there's a bit of a learning curve around OTP, but that's manageable. And then, of course, you get the kind of lumped in, well, you know, you can't possibly succeed using Erlang. And this is really kind of a generic summary of a lot of objections that we heard. Things like, oh, well, you know, I heard that you had a problem last night. That's clearly because you were using Erlang. It's like, no, it was because there were, you know, ACLs on a firewall that weren't right. It had nothing to do with Erlang. Or, you know, why can't you talk to 100 instead of 50 devices at a time? It must be because you're using Erlang. It's like, right, because Java can talk to 100 devices at a time, no problem. And this, again, you know, it falls back to education, right? But I think the bigger issue is we succeeded, right? I mean, it's like people come to us and they say, hey, you know that thing you did? I could have done that in 10 minutes in Perl. It's like, oh, really? Well, do you think you could back up 8,000 devices in 38 minutes? No. Didn't think so. So, you know, if your mouth writes a check, you got to be able to cash it. So finally, I was really hoping that I would be able to post a GitHub URL up on here today. But the 3 libraries that I talked about today are in the process of being open sourced. They're still wending their way through Rackspace's IP process, but I expect within the next week or so that these will be available. Follow my GitHub and Twitter accounts if you're interested, and I will also probably announce this on the Rackspace blog. But we're very excited about this. When I started, I told my boss, we use a lot of open source software. I think we need to give back. And he said, absolutely, I support you in that. And 2.5 years later, it's like, hey, remember that promise you made to me? I'm calling you on it. So keep an eye open for this. I particularly like the gen script. It's not a lot of code, but it is really powerful. So let's hear some questions. What do you guys want to know about? Yes?
How many Erlang developers do you have?
So right now, there's myself, and there are two Ruby programmers that we're training up in Erlang, and we just hired an Erlang programmer who is starting later this month. That's an interesting point. Most of this work was done by me. I wrote about 80% of the code in these applications, simply because we were working often we were considered a part of network security at the time. It's not a development group. It was a support group. And we didn't have a lot of scrutiny on us, which meant that we had flexibility to do what we wanted. But it also meant when we said, hey, we totally need more headcount, that it was like, why? What are you guys doing that needs more headcount? Good stuff, promise. Yeah. Anything else? Yeah?
Do you run it on one server?
So no, we have. So we run on VMs. Right now we have 2 VMs that handle our backups and updates. We have 2 VMs that handle the API calls for the Rackspace control panel, and we have 4 VMs in each data center to handle our switch APIs.
How the work is distributed between these 4 VMs that do backup? Do you just partition the set of your devices?
So we have kind of a natural partition in that by data center, right? And we have a proxy that sits in one data center and proxies all of our API calls. And what happens is our clients will call an API or request a resource, really. From this proxy, we look at the resource they're requesting, determine which node needs to answer that, and then route that to the right node. We are actually working on right now moving our backup and update services out to the data centers as well, so that when we're backing up a device, we're doing it from a VM in the data center where that device lives. And we're actually kind of working right now on how do we get all of these nodes talking? How do we handle things like which device in the cluster is responsible for doing backups? Where does that runner live? And how do we distribute workers across those nodes? Those are things we're actually working on right now. Anything else? Yes?
How do you handle the deployment and update of the Erlang code?
That is a good question. There's 2 answers to that. For the most part, right now, we use Capistrano to do deployment. So for those of you who aren't familiar, Capistrano is a Ruby deployment tool, which is basically just allows you to run commands over SSH on a bunch of different servers in parallel. So what we do for Erlang, so all of our development happens on these Mac laptops, but we deploy to Red Hat. So we have build servers out in the DCs, and whenever we get ready to deploy, our script will head out to the DC and build the release, right? So we use rebar, do the rebar generate, build a release package, and then we use rsync to sync that onto all of the nodes that need that release. And we have heartbeat monitoring turned on. So basically, we just kill the PID, and the heartbeat monitor brings it back up. We can get away with that right now because there are certain maintenance windows within Rackspace where everything shuts down. So if our API goes down for 2 seconds while the VM reboots, nobody cares. We're actually working on, so kind of like the next generation of this, we do weekly releases of the production code and release to staging multiple times per day. We're actually looking at doing the actual full OTP release process so that we can update the API nodes without taking them down, and we're still working that out. Any more questions? All right, guys.
Well, thank you so much, Phil.
I'm on the internet.